So there's many ways to approach this problem, but what I'm going to do is, since it's divide, I'm going to flip and then cross off. I'm going to factor and then cross off. Now I'm the type of person that wants to deal with the numbers first. So 15 and 25 divide by 5, 3 and 5. Negative 10 and 5 is negative 2. A negative 2 and a negative 14 is a positive 7. So when I look number-wise, I have a 3, and a 7, which turn into 9/7. This one is nice to have a highlighter. You have 3, you have 14, you have 3, so 17, 20. 3 plus 3 is 6, 14, 20. Good, good, good. Done, done, done. And then I have 7 on the bottom, that's 14, plus 1 more is 15. And I'm going to circle this to remind me about it. So 7, 8, 15, 5 more on top, 9/7, and then my x plus 6 is on the bottom. State your restrictions. X cannot equal. Okay? Remember to check it. You could take this entire question, set it equal to the answer. All right, vertical asymptote. The vertical asymptote, set the denominator equal to 0, x equals 5. Horizontal asymptote, as long as there isn't a variable on top, the horizontal asymptote is just right there at y equals 3, straight shooter. The zeros, okay, this seems confusing because I might not have said it, but the zeros is what's on top. But there is no x value on top, so there are no zeros, okay? And then the holes, there aren't any holes because that's when you have a match. The new function is the same thing as the old function. But the reason I did this is because I wanted you to see the differences between these two. Transformations, horizontal translation, 5 units right. Don't write that. You have to write horizontal translation, 5 units right. Vertical translation, 3 units up. Okay? The next one, obviously way more complex. Take out a 2x. X squared minus 6x minus 7. I'll factor that again. Let me rewrite it. 2x, x minus 7, x plus 1. Square root, x minus 1, x plus 1. Now before I just throw up the VA, which is setting this equal to 0, I need to be aware that there could be holes. So if you look, here's my hole, and we know we set it equal to 0. It's at negative 1. So if I do that, let me write my new function. H of x equals 2x parentheses x minus 7 over x minus 1. Okay? So I'm going to use this new function, which I guess I'll write over here, to get my information. So vertical asymptote, set the denominator equal to 0, x equals 1. The horizontal asymptote is affected by the degree. You could either look at the original function or the new one. If you look at the original function, you probably want to distribute so that you know that this degree is higher than this one. And this degree is higher than this one. So if the degree is higher on top, there is no horizontal asymptote. The zeros set the numerator equal to 0. If I set 2x equal to 0, I get 0, 0. Write it as a point. If I set this x minus 7 equal to 0, it's 7, 0. Now I've done almost everything except find the y value. So I'm going to plug negative 1 in there. I'm going to go 2 times negative 1 minus 7 over negative 1 minus 1. Negative 1 minus 1 is negative 2. Negative 1 minus 7 is negative 8. 2 times negative 1 is negative 2. A negative times a negative is a positive. So my y value is negative 8, and I can check it by graphing. I could go to my x value. That's why you got to show work. I could go to my x value in my table and see if negative 8 tells me it's undefined. Okay. All right. For this one, I actually want you to graph, find the vertical and horizontal asymptotes. But before I do that, you know I'm going to factor to make sure there aren't any holes. And then this is x plus 2. Okay. So VA, x equals 0, x equals negative 2. So x equals 0, x equals negative 2. Horizontal asymptote, I'm going to look at the degrees. Well, the degrees are exactly the same, so I go 2 over 1. So my horizontal asymptote is at y equals 2. To get the zeros, I set the numerator equal to 0. Let me actually graph y equals 2. Dashed, 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 dashed. And then to get the zeros, I set the numerator equal to 0. If I set this equal to 0, I get negative 3 comma 0. If I set this equal to 0, I get 3 comma 0. And I can't set a 2 equal to 0 because I'm solving for x. So I plot 3 comma 0 and I plot negative 3 comma 0. And then what I'm going to do is pause real quick, graph this original function, and then copy it. So I just graphed the function, and it looks like it's going like this, almost hitting the pink. Whoopsies, but don't hit the pink. Almost hitting the blue, but not hitting the blue. Almost hitting the pink and blue. And I'm happy, but make sure you show me everything else. Study.